In this tutorial, we are going to talk about performing mathematical operations on rational numbers. Well, as we have learned so far, that rational numbers are numbers that could be either integers, they could be whole numbers, natural numbers, or they could be fractions, correct? That entire spectrum of numbers is rational numbers. So when we talk about performing operations on rationals, it's no different than performing operations on either integers or on fractions, correct? So let's take some examples here. And first we will learn about addition operation on rationals, okay? Let's say my number is 5 over 9 plus 2, okay? These are two rational numbers, right? So how do you add them together? I'll follow the same method as we have done in fractions, okay? What we do is, first we convert this integer into as in a fraction, correct? Now, what happens in a fraction addition? What we look for is a common base, and once the base is same, we just add the numerators. Remember the discussion in fractions? So the next obvious step for me is to convert this number 2 into a number which has the same base as 5 over 9. Meaning if I multiply 1 in the denominator with 9, I get 9. So I have to multiply the numerator of this number 2 over 1 to 9 to keep it balanced, right? So this gives me a number which is a new number such as 5 over 9 as it is from here, correct? Plus 2 times 9 is 18 and 9 times 1 is 9, correct? And this leads to the common base situation because these two fractions now they have the common base. So it becomes 9 and 5 and 18 will get added because they both are numerators and my result is 23 over 9, correct? Let's look at the case of a subtraction. The two numbers that I'm subtracting are, let's take 5 over 8 less 0.25. So here I'm subtracting a decimal from a fraction and they both happen to be rational numbers. I can rewrite this expression as this: 5 over 8 as it is minus 25 over 100. Two decimal digits, they become two zeros in the denominator, correct? Okay, now what do we do? What do I see as common between this 25 and 100? I see that 100 gets divided by 25 completely, correct? So 25 goes 4 times into 100. So if I were to rewrite above expression, it becomes 5 over 8 minus 1 over 4. That 1 over 4 is coming right from here, correct? It's a simple case of two fraction subtraction and they do not have common base. What I can do is to convert that into a common base, all I'm going to do is multiply both numerator and denominator with 2 so that 4 times 2 is 8, which is the same base as 5 over 8. Simple enough, right? And this becomes 5 over 8 minus 2 over 8. 8 comes in the denominator from the subtraction and numerators will get subtracted. Hence, this final result will be 3 over 8. And that is my final answer for this subtraction, 5 over 8 minus 0.25. So once again, I did not do anything different compared to what we have learned in the past in the case of fraction subtraction. Absolutely the same method, same style, same concept. Let's quickly talk about a multiplication problem for two rational numbers. Two numbers for the multiplication that are given to me are 3 over 8 times 8 over 24. Two fractions, two rationals, correct? And what we have learned in the past about multiplication of fractions, in this case which is rationals, is that numerators will get multiplied and so will denominators, correct? And there goes our multiplication. Now we can get rid of common numbers. 8 cancels with 8, 3 goes 8 times in 24 and hence it becomes 1 over 8 as my final answer. Or you could have also said that instead of doing it like this, I could have simply done that right here in the problem statement itself. 8 cancels, 3 goes 8 times in 24 and this will be 1 over 8. Either way, whether you take this approach or whether you take this approach, you are going to land into the same answer, but this approach in which you are cancelling all the common factors right from step 1 is a little bit faster, correct? and this is my answer for this multiplication. So let us look at the case of a division problem now. Divide 25 with 5 over 6. Okay, I have an integer and a fraction, and they both are rational numbers in this case, correct? So what I'm going to do is, first I'm going to convert both into fractions. It's just a little bit easier to comprehend. Okay, so this becomes 25 over 1 and 5 over 6. Division sign remains as it is. Now you're dealing with the case of division of two fractions, and what is the trick you have learned in the past? The trick we have learned is write first fraction as it is, 25 over 1, convert the division sign into a multiplication sign, and flip the second fraction, which is a divisor, 5 over 6, find an inverse of that. An inverse will be 6 over 5, and that becomes in multiplication with fraction 1. That is the concept we have learned in the past, right? Now at this stage we are looking at what are the common factors between numerators and denominators, and I see that 5 divides 25 completely, it becomes 5, and hence it becomes 5 times 6, that is the numerator now, and the denominator is 1 times 1, which is 30. Simple enough, 30 over 1, or you could rewrite just as 30 as it is. So the key point of this exercise is, when we talk about performing mathematical operations on rational numbers, it is nothing different whether you're dealing with integers or whether you're dealing with fractions or decimals. The concepts of division and multiplication will be exactly the same what we have done in the past. I will recommend our students to go practice as many problems as we can on rational numbers, and we strengthen our mastery on this concept.